Welcome once again to the Zener Diode lecture series. Earlier we had two lectures in this series and there we have discussed Zener Diode as voltage regulator. So here we are going to solve one numerical on the Zener Diode voltage regulator. Those who have not seen the previous video, in this particular video I have discussed this particular numerical where you can see the power rating Pz for the Zener diode was given and the entire numerical has been solved. Link is this one. Also I will give this link to the description box as well as in the I button. Now for this particular lecture we are going to take this problem. Here you see the circuit and we need to determine VL, VR, IL. What are given? We have been given the supply voltage as 16 volt, Zener voltage as 10 volt, and for load regulation we have 1.2 kilo ohm and in case 2 we have 3 kilo ohm. So both the cases we shall take on. Now let us try to solve this problem. So here we have been given Vz. So see here the value of this R is not given but we need to find VR. So directly we shall apply KVL here and we know what all voltage drops we have here, that if we sum up that will be 0. So that means we can say 16 that is equal to VR plus Vz. Vz is given to us as 10 volt. So 16 that is equal to VR plus 10. So VR we are getting as 6 volt. So first part is done. Now second thing, VR we have found. Now we have to find VL. Now you see this diode is operating in the breakdown region. So Vz is constant, which is 10 volt. So that means voltage across RL, which is VL, will also be constant and that will be equal to VL. So we can say Vz that is equal to VL that is equal to 10 volt. So this one also we have found. Now we have to find IL and we are given that the RL is 1.2 kilo ohm, case 1. So let us take the case 1. So in case 1 RL is given 1.2 kilo ohms. So IL is what? IL is the current through the resistor RL and the drop across the resistor is VL. So IL equal to VL divided by RL. So we are getting it as 10 divided by 1.2 into 10 to the power 3. So pause the video and do the calculation of your own. So I have pre-calculated this and this value we are getting as 8.33 into 10 to the power minus 3 ampere, which is 8.33 milliampere. So case 1 we have found that IL is 8.33 milliampere. Okay, so now we shall go for the next one. The same case, all the parameters are same, only we have now RL value which is 3 kilo ohms. So voltage across the VL is not changing because Vz is not changing. So we are having IL that is equal to VL by RL. So that is 10 divided by 3 into 10 to the power 3, that is kilo ohms. So earlier we have done this one. So in the same way, if we do this calculation, so we are getting this as IL is equal to 3.33 into 10 to the power minus 3 ampere. That is IL is 3.33 milliampere. So that means for the load regulation, we have found if RL is having a range from 1.2 kilo ohms to 3 kilo ohms, then the load current will vary from 8.33 milliampere to 3.33 milliampere. So that is our conclusion. So here we end this discussion. Thank you.